Recall overloading operators. That's where we take a regular operator that we use for integers or doubles that we're used to the definition, like subtracting, the minus sign, or a comparison of the two equal signs that says, are these two values the same? We can overload operators in C++ so that we can make our classes operate with the same operators as the doubles and the ints do. And so here's an example where we're overloading the subtraction operator and the comparison of equals operator. And remember that the left-hand side, so here's an example, we have 0.1 and 0.2 declared, and we're calling that subtraction. And because that subtraction is of 2 points, it looks into the 0.2D class to find that definition. And remember that the one on the right-hand side is the one being passed in, so it's being called right here. And the one on the left-hand side, 0.2, is this. So we're going to take this x minus the right x and square that and add that to the difference of the y values squared. And that gives us the distance between 2 points. And so that distance is actually a double, so we can choose to return a double from the subtraction operator. We have another example where we're doing a comparison, and so we want to check if two things are equal, so that's going to return a Boolean value, so we can find out if it's true or false, whether these two items are equal. Well, a point is equal if both values in the point, both the x and the y value of the points match. So here's an example. We're going to use these same 2 points, and we're going to check if 0.1 is equal to 0.2. Well, 0.1, this x and this y are coming from 0.1, and 0.2 is the right-hand side, so that's the parameter being passed in, so we're checking if those match to the right-hand side, and if they both match, it's an and, so they both have to be true for the result to be true. It will return true for the operator equal, otherwise it evaluates to false. So we're able to implement operators and then use those operators just as we would have used them for something like an integer value. Now, it makes sense to implement subtraction truly as subtraction, and it makes sense to implement a comparison of equals truly as checking as it's equal, but it's up to the user to implement those correctly, and therefore you can change the meaning of operators. I don't advise it. It would make your code very, very confusing, but it is up to the programmer to make sure that they keep those definitions appropriate to the meaning of the operator. You cannot change the number of operands for an operator. If you don't have the correct number of operands, it won't actually be overloading the operator. The return type is not as particular. However, you should return the appropriate type. So if you're doing a comparison, it should return a Boolean value. So here's some examples of operators that can be overloaded. It's not an exhaustive list, but there are a few operators that cannot be overloaded, and they're listed down here. So the if condition with the question mark, the scope, using a size of, those things cannot be overloaded. Let's look at what we need to do to overload our stream insertion and extraction. Now, when we do an insertion, we're actually using a stream on the left-hand side to pass in the class on the right-hand side. So far we haven't actually tried to implement that. Instead, we had just some method on our class called display, and then within the display we called cout to write out the details. Well, we can actually overload our stream operator such that we can pass in a variable that's of a type of a class and use that insertion operator to write it to C out directly. And we have to do that with operator overloading. Now the hard part is that the left-hand side is not actually the same type as the type that we're trying to stream to it. So for example, when we did the subtraction, we were subtracting 2 points, and that was the same as if you had your edge and you implemented operator minus on our edge. So it's on point 2D, so this is the edge, and we're passing in the center. Well, we can't do that for C out because we don't want to define the operator on C out. We want to define it for center. So it would be like the C out has an operator insertion, and we want to add the ability to pass in something that is a class as the value. And in order to do that, we're going to take advantage of our friend function that we just learned. So here is how we set it up. We declare it as a friend. So when we're declaring it as a friend, then this is just our prototype, our declaration. We're going to say that we're going to use an operator insertion that returns an O stream. And we return the O stream so we can chain things together, have many insertions in the same statement of code. And we're going to pass in the left-hand side as the O stream. Remember the C out on the left-hand side? And then as a right-hand side, we're going to pass in our point. By declaring this as a friend, now we have access to the private parts of the point to make our writing out of the private data members in our display easier to access. Here's our definition. Now notice that this is not defined, it's not scoped to any particular class. It's just a function, and we're passing in the O stream and the point that we want to print out. Now, if we pass in C out, that's the same of saying C out, arrow, arrow, then P. So here we have, we're going to write to this O stream. Could be C out, it could be a file stream that you're writing to. By declaring it as an output stream, we could use either write to a file or to standard out with the same function. And what we're going to do is write to that, and we're going to format our point by putting parentheses around it, and then writing out the X and the Y values separated by a comma and a space. So that's going to format our point in an XY format in parentheses. And then if we return our O stream, it will allow us to chain things together. Let's just click right out how that would work. So we could say to C out, we want to write out point 1, and then we'll put a space, and then we're going to write out point 2. Because of the chaining, returning the O stream, you will be able to chain these together, do these 3 insertions in the same line. If you forgot to return the O stream, then just the single one would work, but the chaining would not work. And so you're going to be implementing an operator overload of the insertion in your lab, and you now have all the information you need to complete your Lab 9. Just one other quick little topic that I want to bring up. You've noticed that when we do things like assigning an integer to a double, there's no problem with it. It does an automatic conversion of the int into the type double for us. Well, you can actually define those as operators for your classes. So for example, if I had a class called feet inches, and I defined the operator int parentheses and had that return feet, which is an integer, that would allow me to assign something like this variable distance that is of type feet inches into an integer. It will see that this is not the right type, and then it will check for an operator that will convert it to an int, and then automatically do that conversion that's specified here so we can assign an int to this d variable.